Hi, in this video we learn how to use the Excel spreadsheet to find the range, the variance or the standard deviation of a large sample data. So in this problem we are given the magnitudes in the Richter scale of the 120 earthquakes in this table, and we are trying to use any technology to find the range, the variance or the standard deviations. Now, it is very difficult to use the TI-83 or 84 to enter all the 120 data into the list so that you can compute the range, the variance or the standard deviations. So imagine that I use the TI-84 and then let me turn this on and then go to the stars, edit, and then enter 120 points, the 120 sample data points to here, and compute the sample statistic. It's take a lot of time for us to input the data here. That's why I'm not using the TI-84 in this case, but from my MATLAB they have the option that you can open this one in Excel, and if I open that, I can go ahead and find all the sample statistic on Excel. It's very quick. Okay, so here let me show you. We got the Excel spreadsheet here, and then we have 120 data points, the same thing as you see here. Okay, so the first question is that without the extra data value, so in the later question we add another value 8 and then we recompute the sample statistic, but before that we do not take number 8 to our data. So there are only 120 data points that are here. So the first question, the range. So we know that the range is just the maximum value subtract the mean value from all the data points. So how do I find the max and subtract the mean? Unfortunately, on the Excel spreadsheet we don't have the function to find the range directly, but we know that the range is equal to the max value of the data points subtract the mean value of the data points. So all you can do now is we use the max function and the mean function and then just do the subtraction, and that should give you the range. Okay, so let me do the range here. So for the Excel spreadsheet we put the equal sign to stack the formula, and then we use the max, max. This is the max function. It returns the largest value in the set of data. Okay, so click on that, and then we go up to the top, and then we just highlight all the data points. Okay, so highlight all the data point up to the last one, so that the function will find the largest value, so up to 120, and then close the parentheses and then hit and then we do the subtraction. We're not done yet, and then we take the max value, subtract the mean value to get the range. So do the same thing. This is the mean value, and then open parentheses. The same thing is going from A1 to A120. That means we take the values data from column A1 up to A120, and you just have to type it in this time. So A1 go down to A120. You can highlight, use the mouse to highlight the columns, or just enter A1 columns A120 and then close the parentheses. So we take the max, subtract the mean value of the sample points, the sample data, and that should give you the range, right? and that equal to 3.5. So we know 3.5 is the range for this 120 data points. So 3.5, and then check the answer. Fantastic. Okay, good. Now we need to figure out what's the standard deviation for this 120 data points. So the same thing, we hit the equal sign, and the sample standard deviation should has the name of STD. STD is standard, right? Standard deviation. And EV, so this is the standard deviation, so it has the name of STD-EV for the standard deviation. ST is the standard, and then the last 3 is deviation. Now there's a few different types for the standard deviations, but we should pick the one that .s here. Why? Because this is the estimation for based on a sample. We have the data of 120 samples data. It is only the sample, it is not everything. So that's why we pick the sample. .p means that we calculate the standard deviation based on the entire population, but we don't have the entire population, we only have the sample, which is 120 points. That's why I use the sample here. So .s, so click .s, and then again we pick the value from the top to the bottom to include all the data points. So I go A1, which is the top, colon, and then A120, go to the last one. So A1 is always on the top, and A120 is the last data point, and then close the parentheses and hit enter. That should give me 0.652, and they ask you for 3 decimal places, so 0.652, and then hit the check answer key, and that is correct. Now the next one is the variance. The variance is what? The variance is just the square of the standard deviations, right? It's just a square. Anytime that you get the standard deviation square, take the power of 2, and that should give you the variance. So because we got the value for the standard deviation up here, so all you do now is you take this number, square it. So I can do it here. So putting the equal sign, and then I click on this number, right? And then I take it to the power of 2, right? And the power, we use the hat, so use the shift number 6 to get to the hat symbol. This is to the power, and then up to enter number 2, and then hit enter. So it's give me 0.42548, and I used only 3 decimal places, so 0.425, and then check the answer. Well done. Okay, so the next value. Now with the extra data value, that means if we have another value 8 that is added to the list of 120, so now we have 121 data points. Now what is the new range of that? Now let's go back to the Excel spreadsheet here. Remember that we add another value to the list, so I put it in here. That is number 8, so I put 8.00 and then hit enter. So that means I include another new data point. So the total now, we have the total of 121 data points. Now what should be the new range? Again, we have to redo it. Okay, so I redo it here, putting equal sign, the range is equal to the max value from the list subtract the mean value from the list. So I put the max function max and then open parentheses, and then now I just go all the way up to the top and then select the value from the first one, scroll down, highlight all the value until 121 up to the last data point, which is number 8. We just add that and then we stop there and then close the parentheses. That is the max value, and then subtract the mean value, the same thing. Now we go from A1 down to A121. So I just hit the key letter A, number 1 colon A121, and then close the parentheses. So the max value subtract the mean value should give me the new range, and that should be 6.86. 6.86. Okay, that's good. And then let's do the same thing for the new standard deviations, and go back here. That's equal sign st standard dev standard deviation, and this is the sample, the list of the sample. So we use the dot s for the sample. So dot s, and then opens, and then we know that the list go from A1 down to A121. So I put A1 colon A121 and then close it and then hit the enter key. And then the new standard deviation should be 0.818, but after number 8 here, let me zoom this. After number 8, we see that this is number 5, the digit 5, which is equal or bigger than 5. That means we can round it up to 0.819. So 0.819, and then check the answer. Well done. The next one is the variance. The variance is just the square of the standard deviations. So all we do now is we hit the equal sign, and then I take the standard deviation we just got, and then the power up to, and then hit enter, and that should be 0.670, 3 decimal places, and then we check the answer, and that is correct. Now do the measures of variation change merge with the extra data values. So we can see that the old range was 3.5. The new one with the extra data value is 6.86. So 3.5 go up to 6.86. We can see that 3.5 and it's almost double, because this is almost 7. 3.5 double is 7, right? So with just one extra value, and it makes the range almost double. So of course it's more than 5 percentage points apart. Okay. And then for the variances, now the old variance was 0.425. Okay, the new one was 0.670. So how do I find the changing? Well, we can take we can go back to the calculator here and compute the differences. So I took the old value. Sorry, the new value was, we are talking about the variance. So I take the new one, 0.67, okay, 0.670, subtract the old variance 0.4425. So this is the difference between the new and the old variance. And then we take this value, divide by the old one. So 0.245 divided by the old one, 0.425. and then we multiply by 100 to get to the percentage. So the changing was 57.64%, and that is more than 5 percentage points apart. Okay, and the standard deviations, we do the same thing here. I take the new standard deviation, which is 0.8, 0.819, subtract the old standard deviation 0.65, 0.652, and then I get the value, the difference, and divide by the old value. So 0.167, and then divide by the old standard deviation, which is 0.652, and then multiply by 100%, and it's give me 25.61% changing from the old to the new standard deviations. So this is more than 5 percentage point, right? So all of them are changing with more than 5 percentage points apart. So we can see that there's some conclusion here. Only the range and the variance change, not correct. All three of them changing. Only the variance changes. Nope, that's not correct. All of them change. Only the range change is not correct. Only the variance standard not correct. Only the standard not correct. Only the range and standard. So all of them change, because we can see this is more than 5 percentage points, almost double for the range, or more than 5 percentage points apart for the variances, and also for the standard deviations. And now let's check the answer, and that is correct. Okay, so that is how we use the Excel spreadsheet to help you to find the sample statistic, including the range, the standard deviations, or the variance from any of the large sample size. That is not practical to use the TI 83 or 84. And thanks for watching.